So at the bottom of our fraction we have x multiplied by x plus 1. We can solve this by using partial fractions, but before we do that, we first have to do long division because this is an improper algebraic fraction. We can tell that because we have a cubic on the top and a quadratic on the bottom. So if we expand this out, the highest power would be x squared. The highest power here is x cubed. So when the numerator has a power which is equal to or greater than the power on the denominator, so in this case x cubed, so 3 is greater than the greatest power here in the denominator, which is x squared, that's when you have an improper algebraic fraction, and then you have to do long division first before you can do partial fractions. So let's expand out the denominator. That would end up being x squared plus x. Our numerator is x cubed plus 2x squared plus 0x, so putting a placeholder there, and then plus 2. So let's start the division off. We can see how many times x squared goes into x cubed, which would be x times. So put x here. And then we multiply the x by what we have here. That gives us x cubed plus x squared. Take the two things away. X squared plus 0x plus 2. See how many times x squared goes into x squared, which is once, so plus 1, times the 1 by this, which is just x squared plus x, take away 2 minus x. So this means that what we have here can be rewritten as the quotient, so how many times this goes into this wholly, which is x plus 1, have that first, plus the remainder is this, 2 minus x, and then that's all divided by the divisor, x squared plus x, which I'll actually write back as x times x plus 1, x times x plus 1 dx, and now we can separate what we have here into partial fractions. So let's write that out down here. So 2 minus x over x multiplied by x plus 1 can be expressed as, in partial fraction form, a over x plus b over x plus 1. We then make a common denominator, so our common denominator in this case would be x times x plus 1. So to get this fraction, having a denominator of this, we have to times top and bottom by x plus 1. So that first term would become a times x plus 1. Similarly, we have to times this fraction top and bottom by x, so plus bx. Left hand side stays the same. We can cancel out the denominators now, and we end up with 2 minus x is equal to a times x plus 1 plus bx. We can let x equal to something which sets one of these two terms to 0. The easiest one to start with would just be x is equal to 0. So let x equal to 0, and the left-hand side becomes 2. That's 2 minus 0. This becomes a multiplied by 1. And the final term would just be 0. So we end up with a is 2. So we want this bracket to now be 0. So let x equal to minus 1. We then end up with 2 minus minus 1 is equal to a times 0, so this becomes 0 now, and plus b times minus 1. 3 is equal to minus b, so b is equal to minus 3. Okay, now we can put this back in. So let's go back up to our integral, which was up here. So it starts off with the integral of x plus 1. So x plus 1, and then we have this fraction here, which we rewrote as this, a over x plus b over x plus 1. So a is 2, so it will be plus 2 over x, and then b was minus 3, so that will be minus 3 over x plus 1. And now we can integrate. So integral of x would just be x squared over 2. Integral of 1 would just be x. 2 over x is just the same thing as 2 times 1 over x, and 1 over x integrates to make ln x. So the next term will just be 2 ln x. For the minus 3 over x plus 1, we can rewrite that as minus 3 multiplied by 1 over x plus 1. And 1 over x plus 1, that will integrate to make ln of x plus 1. If you were to differentiate this using the chain rule, you'd get y is equal to ln u, where u is equal to x plus 1. And then differentiating each of these parts, we'd get 1 over u times the differential of this, which is just 1. So that would then just be 1 over u, which is x plus 1. So now you can see how this differentiates to make what we have here. We have a minus 3 in front, so we just put that minus 3 in front here. So that last term would just be minus 3 lots of ln x plus 1 plus c, and that would be our final answer.